Hey y'all, it's me, Miss B. Today we're simplifying radicals and multiplying radicals. Let's start with a few warm-up exercises from the 6.2 day 1 notes. Okay, we're just going to do this one here. Now, this is the square root of 50, x to the 5th. So if you remember back, we take the square root by splitting it into two roots, a perfect square, and what's left over. So 50, perfect square that divides 50 is 25, and 25 times 2 is 50. And so we can split this into the square root of 25 times the square root of 2 times the square root of x to the 5th. Square root of 25 is 5. We have radical 2. And then x to the 5th, what we do is we take 5 divided by 2, and we get 2 remainder 1, which means that we have x to the 2 on the outside and x to the 1 on the inside. So I'm just going to leave it as x since that is there. So these match up. Okay, so there's our answer with that one. Here's another one. So taking a cube root, we got to think of a perfect cube. So 3 to the 3rd equals 27. So that's our perfect cube. So take the cube root of 27 times, what is that? 2y to the 10th. Having a little trouble writing here. 10 divided by our index is 3, which is 3 remainder 1. So we're left with the cube root of 27 times cube root of 2, and then cube root of y to the 10th. So we get cube root of 27 is 3, cube root of 2, and then I have y to the 3, y to the 1 in there. Okay, so there is our answer to that one. All right, so when we're multiplying radical expressions, and we have to have the same index, we're going to multiply what's inside the radicals together and multiply what's outside of the radicals together, but we're going to keep the index the same. So with these problems, we were kind of splitting it up. So we did 54 is 27 times 2, and we split it into 2 pieces. Now we're going to multiply those things together. Okay, so here I have my first example. What I'm going to do is I have an index of 2 right here because it's an invisible 2. And so I'm going to keep my index the same, but I'm going to do 12 times 5 under here. So 12 times 5 is 60, so I get the square root of 60. Goodness gracious. All right, this next one here, take the cube root, negative 4 x to the 4th times 4x. So just multiplying what's underneath there. So we get cube root of negative 16 x to the 5th, because 4 plus 1 is 5. Then finally, this last one, we can't combine. So it's already simplified. I spelled simplified wrong. Simplified because this has an index of 2 and that has an index of 3. So we can't simplify because they have different indices or indexes. So we'll just like index. All right. So here are steps. We're going to multiply the inside and the outside together, and then from there we're going to simplify. So in these beginning problems, we just left them, but we can simplify these further. So I've got 8 to the square root of 8 times 6, so this same thing as that, which is square root of 48. Then I ask, what perfect square divides 48? So 16 actually is a perfect square that divides 48. Oh, times 3, not 4. So we have the square root of 16 times square root of 3, which gives me 4 radical 3 as my answer. So we're kind of taking our two parts. It's funny because we split them, we put them together and then we split them up again in order to simplify them. Okay, let's take a look at this next one. So let's multiply what's outside the radicals together. So 2 times 3, and then 5 times 5, so the insides together. So we have 6 radical 25, and the square root of 25 is 5, so 30 is our answer there. And that's it. So just to kind of go through it a little slower, multiply the outsides together, multiply the insides together because we have the same index. We get 6 in square root of 25. Take the square root of 25, that's 5, multiply it by the outside, and we get 30. All right, so let's do one more together from the DIY section. We're gonna go down here to this one. Okay, so keep our index the same and multiply what's underneath. So 6x squared times 16x to the 4th. All right, so then we do 6 times 16 and get 96. X squared times x to the 4th gives me x to the 6th. All right. So then, I'm not sure perfect cube goes to 96, so let's list them. 1 to the 3rd is 1, 2 to the 3rd is 8, 3 to the 3rd is 27, 4 to the 3rd is 64. Can't be any more than that, so let's do so 96 divided by 8 is 12. So we're gonna do 12 and 8, and it is a little bit of a trial and error there, and then x to the 6th. And I did forget my 3 on those ones. Okay, we're gonna do 6 divided by 3 for that index there, and we get 2. So this 8 moves to the outside, so we get this 8 moves to the outside, and we get x to the, we get 2, and then this x to the 6 becomes x squared, and then that 12 stays on the inside. Okay, and don't forget your index. So that right there is our final answer. Okay. Let's maybe do one more. Let's do this one here. So I've got the square root of x to the 5th times square root of 3x. Multiply on the inside, so we get 24. Let's write that out. 8x to the 5th times 3x. Then we get 24x to the 6th, because this has an exponent of 1. a perfect square that divides 24 is 4. Okay, so then we take that 6 and divide it by 2. Gives us 3. So we get, and taking the square root of that 4, gosh darn, we get 4, oh wait, sorry, square root of 4 is 2x to the 3 times the square root of 6, and that right there is our final answer. Okay.